A force vector F in a 2D plane has a magnitude of 120 newtons and is directed at an angle of 40 degrees counterclockwise from the positive x-axis. Determine the components of F in the standard horizontal vertical coordinate system. A second reference frame x', y' is obtained by rotating the original axis counterclockwise by 75 degrees, and we want to determine the components of F in this rotated coordinate system. You may assume all axes are right-handed and all angles are measured counterclockwise. Remember to try solving this problem yourself before watching the solution. This is the first example for the Dynamics Intro and Math Review 11-minute lecture video. The links to the other examples on this topic and the other lectures of the Dynamics course are found in the description below. As explained in the main lecture video, we know that the horizontal component of a vector can be calculated by multiplying its magnitude by the cosine of the angle between the vector and the horizontal line. The same is true for the vertical component when using the sine function. Substituting the magnitude and the angle value, we get the two components. For the second reference plane, we can calculate the angle between the vector and the horizontal equivalent axis to be minus 35 degrees. If we use the same definitions for horizontal and vertical components of that second reference plane and we substitute the values, we can easily find the components. As pointed out in the main lecture video, we don't need to manually add a negative sign. This is also true for the cosine. The cosine of an angle between 0 and minus 90 is positive. We don't need to manually make it negative. These two values make sense since we see that the component in the x' is still positive from the 0 value or origin, and the component in y' is negative as it is moving in the negative direction from the 0 value or origin. We can express this vector following unit vector notation if we use I and j for the unrotated frame and u and v for the rotated frame. If you want to check out other examples for this same intro topic, the main lecture video, or other lectures of the Dynamics course and the other engineering courses, make sure to check out the links in the description below. Thanks for watching.